Hi everyone, here's our math problem for today. This is about estimating the value of logarithms. Let's say the problem is, without using a calculator, estimate the value of the logarithm of 3 to the base 2. And we are given these four options. Letter A between 1 and 1/3 and 1 and 1/2. Letter B between 1 and 1/2 and 1 and 2/3. Letter C is between 1 and 2/3 and 2. And letter D between 2 and 3. Now let's solve this problem together. Let's begin by letting the value of the given logarithm to be equal to x. Now, when we estimate the value of a number, we usually want to know a range of values, and let's call those range of values as the upper bound and the lower bound. So we want to find a value for x from certain lower bound up to certain upper bound that we are very sure enough to be the known extreme values of the number we are estimating. Let's transform first this given equation into its exponential form. So x equals the logarithm of 3 to the base 2 is equivalent to this base 2 raised to x equals this 3. Then let's raise this equation to the third like this. And simplifying, we know that 3 cubed is equal to 27. Our base here is 2. So we are looking for an exponential number with a base 2 that is close to 27 but a little higher than 27. And that number is 32, because 32 can be written as 2 to the 5th, while 2 to the 4th is 16, which is still less than 27. So, since we are estimating here for the upper bound, we want some number that is greater than this 27. That number must be an exponential form with a base of 2, and that number is 2 to the 5th, because 32 is equal to 2 to the 5th. So we now therefore say that this exponential number, 2 raised to x, all raised to the third, is less than 2 to the 5th, and we are sure about it. Then let's recall some properties of exponents. We can simplify the left side using this power about power rule by simply multiplying this x and 3 to get 2 raised to 3x. Notice now that we have base 2, we have base 2 here at the right side, then this exponent 3x must be less than this exponent 5. So we now arrive at this result. 3x is less than 5. And solving for x, we have x is less than 5/3, or x is less than 1 and 2/3. And this is our upper bound. Let's remember this value. Now, knowing what's the upper bound of this expression, we now solve for the lower bound. Again, let's write this in exponential form. But this time, let's raise both sides of the equation to exponent 2, and let's simplify. We know that 3/2 is equal to 9. And since we are looking for the lower bound, let's look for a value that's a little lesser than 9 in such a way that its base is 2 also. And that number is 8, because 2 to the third is equal to 8. And so here's now the beauty of this. We have here an exponential number to the base 2. This 8 also can be written as 2 to the thirds, like this. So we now have this left side greater than 2 to the third. So again, going back to law of exponent number 3, the left side of this inequality can be simplified as 2 raised to 2x. And we have the same basis, then this exponent 2x must be greater than this exponent 3, and we now have this result. And solving for x is greater than 3/2, or x is greater than 1 and 1/2. And when x is greater than 1 and 1/2, it follows that 1 and 1/2 must be less than x. And this is now our lower bound for x. So putting this lower bound and this upper bound together, we now have this continuous inequality. X is between 1 and 1/2 and 1 and 2/3. And what is x? X is exactly the logarithmic number that we are trying to estimate. So therefore, we now say that the value of the logarithm of 3 to the base 2 is between 1 and 1/2 and 1 and 2/3, which is letter B. And this problem is now solved. So thank you very much, and we hope to see you again in our next video. Bye for now.